In this video, we're going to use Lagrange multipliers to find a minimum distance from a point to a plane. So we're given the plane x minus 2y plus 3z equals 6, and we want to find the point that's closest in that plane that's closest to the point 0, 1, 1. So if a point is on the plane, then it needs to satisfy x minus 2y plus 3z equals 6, so that's going to be our constraint. If we just have some arbitrary x, y, z, then the distance between x, y, z and 0, 1, 1 will be x squared plus y minus 1 quantity squared plus z minus 1 quantity squared. We'll do the square of that distance because that'll be a little easier to take derivatives of, and that'll be the minimum value that we're looking for. So now we have this set up like a Lagrange multipliers problem, so we'll take the partials of f with respect to x, y, and z, and set it to a scalar multiple of the partials of g with respect to x, y, and z respectively. And then our fourth equation will be the constraint equation. All right, so if we had lambda is equal to 0 again, or say x is equal to 0, then lambda has to be 0. If, in any event, actually I don't need to worry about that in this case, because here I've got lambda is 2x, this is lambda is the negative of y minus 1, and this is lambda is 2/3 of z minus 1. We can equate and solve for y and solve for z. So we get y is equal to 1 minus 2x, and z is equal to 1 plus 3x. So now we can plug these into the constraint equations and the constraint equation and solve. If we simplify the left-hand side and move the constants over to the right, we should get the equation 14x equals 5. That tells us x is 5/14, and then using the other two equations that we have, we get y is equal to 2/7 and z is equal to 29/14. It's obvious, hopefully, that this is the point that gives you the closest to the plane versus the farthest away, or excuse me, closest to the point 0, 1, 1 that's in the plane versus the maximum, because I certainly should be able to find points in a plane that are as far as I'd ever want to get away from a given point. So this must be our minimum distance point here. And so the point that we're interested in is 5/14, 2/7, and 29/14 is the coordinates.